Okay, so we want to look at solving some trig functions. Again, these are not ratios that we're going to recognize from the values that we know. These are not things that we learned on the unit circle, but they're just as valid an equation as anything else. We're going to have to use our inverse sine or inverse trig functions, and we're going to have to use a calculator to find these. Okay, so the first thing when you're solving a trig equation is here we're asked to solve for 0 degrees is less than or equal to theta is less than 360. This is telling us that we want to find the degree solutions in the first rotation. Okay, so on my calculator, I have to be in degree mode, or it will give me the wrong answer, because we're going to have to use an inverse trig function. So I'm going to go to my mode and make sure I'm in degree mode. On this worksheet, at the bottom, it switches to radians, so you have to be aware of that. That's part of the challenge, I guess. So for this first one here, like most times when we solve, we're going to try to isolate what we're solving for. So we'd like to find theta, so let's isolate the tangent of theta. So the first thing we'll do is we'll add 4 to both sides. So negative 0.36 is equal to the tangent of theta. Okay. Now, negative 0.36, we don't know that value. Now, we do know, though, that tangent will be negative in the second and in the fourth quadrant, correct? Okay, now, so to kind of help us there, I'm going to draw a little sketch. So it's somewhere out here in the second quadrant, and it's going to be somewhere in the fourth quadrant. Now, from what we know about the unit circle, these are going to be directly opposite of each other, correct? They're going to be 180 degrees different. Right? So what we need to do is we need to find one of these using our calculator, using an inverse trig function, and then we can use that to find the other one as well. Now, if we take the inverse tangent of negative 0.36, it's going to give us this value right here, correct? But it's going to give us a negative value. So we have a couple options. I usually just leave it positive and find the positive value, then I use that to make the other ones. Okay, it's up to you though. But what I would kind of recommend here is, let's say that theta bar, right, the reference angle, right, the acute angle between the x-axis and the terminal side, is going to be the inverse tangent of 0.36. That's what I would recommend that we do here. Later on, if you want to get fancy and use negatives, you're fine. But this will really work nicely for us. Okay, so to do this, we get that this angle here, let's go ahead, I think we're asked to go to the nearest hundredth. So let's say 19.80 degrees. Now, that's not our answer, because as you look at either one of these two, those are not at a position of 19.80 degrees. Right? That just doesn't happen there. Okay, but what we do know is that this is the reference angle. So that means that this angle here is 19.8, and that this angle here is 19.8. Does that make sense there? So our actual thetas that we're solving for. So if we look at this, so theta will equal 180, which would be halfway around, minus 19.8 degrees. And then this would be a full trip around, wouldn't it? 360. And then we're taking that away, and then 360 minus 19.8 degrees. So our theta values would be 160.2 degrees and 340.2 degrees. Would be the two angle measures that we would get there. So again, my recommendation would be is to get your trig ratio equal to some number, then just take the inverse whatever trig of that number, but just leave it positive. Because we know that whether it's inverse tangent, inverse sine, or inverse cosine, if we have a positive ratio, it's going to put us in the first quadrant, correct? In a first quadrant, we'll have the same measure as our trig ratios. Now, a really nice way to check this here is if we go back to the original equation and I type in negative 4 plus the tangent of 160.2 degrees, it should be really close to negative 4.36. So let's see what that'll give us. It gives me negative 4.36002. That's close enough, right? We had to do a little bit of rounding in there. All right. So our next example here, this is number 3 from the worksheet. It's a little better than number 2. But so with this, again, I want to isolate the cosine value, correct? So cosine of theta, I'm going to add 3 to both sides. So we get the cosine of theta is equal to negative 2.1. Now, we have to know where's cosine negative. Well, that would be in, remember, all students take calculus, so that would be down here in the 3rd quadrant, right, and the 4th quadrant. So that's where our 2 answers are going to be at. Okay, now, we need to find the reference angles that show us what the answers are. Oh, I'm sorry. Oh, this is cosine. So it's 2nd and 3rd. I'm losing my mind there. 2nd and 3rd. Sorry, all students take calculus, so it's positive in these 2, it's negative in these 2. Sorry. Now, if I just do the inverse cosine of negative 0.21, it'll give me this exact value over here, right? But it doesn't really help as much getting this one down here. Does that make sense there? Because it's only going to give us 1 because it's an inverse cosine function. So what I would recommend we do is say theta bar is the inverse cosine of positive 0.21. And then we're going to use that angle right here and right there, right? It's going to be that many less than 180 and that many more than 180 is how I would do that. So let's see what this reference angle would be. So I'm going to do the inverse cosine of 0.21, and that's 77.88 degrees approximately. Bless you. So that would be, now, that means if I took the cosine of 77.88 degrees, I would get 0.21, right? Which is not really what we want. We want negative 0.21. But again, because we're just in the 1st quadrant here, our thetas will be 180 minus 77.88 and 180 plus 77.88. Is that following there? How we would do that? So 180 minus 77.88. So that would give us 102.12. And then I would add 77.8 to 180. Remember, we're always coming off the x-axis, correct? So it's always going to be adding or subtracting to 180 or subtracting from 360. Never 270, never 90. That'll get you the wrong answer most of the time. So here we have 102.12 and 257.88. Now I want to do another one here while we still got a little bit of time. Let's jump down to maybe number 7. Here it asks us to solve for 0 is less than theta is less than or equal to theta is less than 2 pi. So what mode are we going to be in here? We're going to be in radians. So to do this one, you got to put your calculator back into radians. So just to give you a little start here, and I'll stop in just a second, we get the cosine of theta is negative 0.17. So that gives you the cosine of theta is negative 0.7, right? Where's cosine negative? The left half of the unit circle, right? The 2nd and 3rd quadrant. So our answers are going to be over here and over here. So what you can do, here though, we're not using 180 because we're in radians. Okay, so we're going to find this angle, and that's going to be theta bar. We'll find that angle, that'll be theta bar. Our answers are going to be theta bar. Well, sorry, the answers for theta bar, you're going to take this, you're going to do pi minus theta bar, and you're going to do pi plus theta bar. Remember, halfway around is actually pi. So as we look at this one, I would recommend to find theta bar that we do the inverse cosine of positive 0.7, but we have to be in radian mode. So you have to change the mode on your calculator. There's no way around that. You just have to kind of be aware. Whenever you're going to hit a trig button, you got to be in the correct mode. If not, it'll not go well. So let's see, inverse cosine of 0.7. This gives us about 0.795. Nearest 100. Okay, so that's good enough, I guess, there, right? So that's in radians, though, correct? That's why it's such a small number. That's why it's not, 86 degrees like we saw before, whatever it was, 77 degrees. So here for our actual theta values, we're going to take pi minus 0.795 and pi plus 0.795. So again, same idea. We're not using 180 anymore. Now we're using pi. So let's see, pi minus 0.795. So that's 2.35 radians. I'll put radians there just to be clear. And then pi plus that is 3.94 radians. So hopefully you see it's the same process, correct? We're just doing radians instead of degrees. So it's just something you want to be aware of. Now obviously these types of questions you have to use a calculator for, right? So let's just take some time. Let's work on the rest of these and kind of make sure we're getting a good hang of it. If you go to the linked version of this worksheet on the agenda, it has the answers right there. And I have the answers right here too if you want. We can look at some of these. But go ahead, and you can always check them right here. If I took this initial equation and said -1 plus the cosine of 2.35, it should be really close to -1.7. Right? If I did -1 plus the cosine of 3.94, it should be really close to -1.7. So go ahead and try those, and we'll see how that goes.